Morning. Hope you can hear me fine. It's a pleasure to be here. My name is Raffaele Luca Amalfi. I'm the CEO of Seguente.
My name is Tommaso Ferrarese. I'm a global application specialist at Alfa Laval.
Just to give a little bit of context for the presentation, this is not going to be a technical updates. It's more like to present a vision that we are working between Seguente and Alfa Laval on a new technology in the space of thermal management and energy management that we will contribute to the OCP mission. A little bit of background here. We see that in order to support applications like big data, artificial intelligence, 5G, 6G, and beyond, there is we are experiencing a trend for densification, which means the thermal engineers are packing more functionality into the smaller boxes for efficiency and performance. And this trend actually is happening across the multiple market segment in the data centers, as well as in edge the deployments and the overall telecom market, including wireless and networking equipment. Of course, the consequence from packing more functionality is the dissipation of the heat. And this slide actually clearly identified that HPC node and any kind of networking equipment are basically increasing their power density. And of course, these will call for new thermal management technology, as well as also there is the need to accommodate the new processor packaging, which they will have integrated memory and maybe operate at the low temperature. So it's really clear that the power is going up, the operating temperature is going down, so we have to do something new in the space of cooling. A little bit where we have some challenge, and I just would like to highlight very quickly here. It's interesting to see that the Uptime Institute has a report the plot of the power usage effectiveness as a function of time. In the last 9 years, basically this is quite flat and is landing to about 1.57 in 2022, which means that we still have a lot of energy that is not really used for compute, but is just used for operating the data centers and is not quite efficient. So really, we need to do something better, and this is why OCP and the entire community, they are working a lot on trying to promote new cooling technology and energy management technology, and we are listening many talk here about liquid cooling. Why liquid cooling? For 4 main reasons. We need to support the high performance compute and the bandwidth communication application, 5G and 6G, beyond. We have the need to launch new product, new hardware platform, high performance compute. We need to get better in terms of total cost of ownership. This is the key. We need to lower the OPEX over the lifetime of the servers, as well as also this will enable us to improve our joint sustainability goals, because if we reduce the OPEX, we can basically lower the carbon emission and also find a way to better use the heat. What we do at Seguente is an emerging company that I'm leading, is really to look at data centers in an holistic approach. The energy going in, the energy goes out, and we look at the inefficiency across the multiple length scale, for chip to room to be able to improve the efficiency, the entire operation of a data centers. And the main goal for us that we would like to contribute to the OCP is to focus a little bit of something that can be innovating in the space of cooling, and this is the direct two-chip multi-phase cooling technology that we are trying to develop together with an ecosystem of partners. This technology basically leverages the thermosiphon approach. It's a very simple, elegant approach where you have a liquid flowing into the cold plate, and since the fluid will phase change, the vapor basically will have the buoyancy force to drive the fluid upwards to the condenser, which is given by our colleague from Alfa Laval, as we can learn in the second section. The fluid will condense back to liquid, and then the unbalance between the density of the liquid and vapor will trigger the flow circulation in the loop. On the right-hand side, we can see a picture of this product, which is in a pre-production phase using an open compute spec servers, the OpenEdge. And the main characteristic, of course, is extremely high heat density. In a 42U form factor, we can exceed 100 kilowatts with no problem. Very low PUE, as we can see. The water-free in implementation, zero maintenance, high reliability, and the possibility also to install these in existing and new installation. Of course, we all know that to be able to be successful, we need to assure the performance efficiency, but we also need to look a little bit on the economic benefit. And this is a case study that Tommaso and I would like to share with you, with the OCP community, is a modular data center supporting 5G application. The baseline is a 50 kW room that is basically cooled by in-row cooling units. And then the exercise is to consider case one where actually we retrofit with, by substituting, by replacing the air-based cooling with the new cooling technology, by keeping, of course, 50 kilowatts power. And the case two is actually to build a new data centers, which we can use high-performance compute servers, which means the same amount of kW can be given with the less amount of servers and only one rack. And just to share a little bit what we see here, is that compared to the baseline, which is the gray bar, air cooling, with this innovative approach, we can reduce by 95% the OPEX, which means we can reduce a lot the operating expense as well as also the carbon emission. And this, of course, as savings year by year over the entire lifetime of the servers. But then at the same time, we should also look on the right-hand side where we have the normalized CapEx. And it's interesting to see that also this is going down, is very advantageous for three main reasons. The approach is fully passive, so we can reduce any kind of additional cost in terms of auxiliary components. We can also reduce we can simplify the room level cooling infrastructure, which means we don't need any compressor for chillers, as well as also when we go from the baseline to the greenfield application and we use high performance compute, of course we have an economy of scaling which is going to be advantageous to reduce the IT capital cost and reduce the total cost of ownership. Now, just a little bit to transit, as we want to enable something new in this space of thermal management, and it's important to make sure that we have the right supply chain in place. And this is why Seguente has done a partnership with Alfa Laval to make sure that we can bring this technology to the next level. With that, I would like to ask Tommaso to take it over. Thank you.
Thank you, Luca. So when it comes to liquid cooling, several technologies are in the market. We have a direct-to-chip that we just saw with Luca, but we have others, immersion technologies, one-phase, two-phase. What all these have in common is that they have to overcome some challenges. These challenges are increasing power density, reliability, maintenance space. There are a lot of challenges as we are seeing and hearing in this conference. The solution to have a success to overcome these challenges is our partnership. And this is what we are going to see in the next slides, the partnership that we had with Seguente. Why a global supplier? A global supplier is providing a global reach. It has a local presence with service locally. It has a supply chain that is spread all over the world, so it is more reliable. But more importantly, it provides experience in several markets geographically, but also in terms of different applications. And the R&D of a global supplier can look at the far future and not only on the day-to-day. Just one small slide to remember to who is less confident, what is a brazed plate heat exchanger. We are talking about a plate heat exchanger with stainless steel plates brazed together with copper to produce a single element that is maximizing the efficiency by dedicating the whole material to heat transfer. Alternate channel with the two fluids are exchanging the heat in the most efficient way. And there are ways to optimize this heat exchanger according to the application, according to the refrigerant, according to the conditions. Here we have two examples: asymmetry, having channels of different volume to adapt to the pressure drops of the two different fluids that you can have inside the heat exchanger, and of course the possibility to customize, to design the channel plates in order to be more adapted to a certain application or a certain refrigerant. This is what we do in designing heat exchangers. And then it is all about flexibility and capability to adapt. We have two slides to show that. from two perspectives, I would say. One is the flexibility among different applications. Heat exchangers are used in several applications: air conditioning, heat pumps, refrigeration, data centers, engine cooling, you can go on. What happens in all these applications is that the heat exchanger manufacturer is able to cooperate, to have partnership with the biggest player in each market. For example, in air conditioning, we can have a partnership with the major companies on air conditioning to optimize our heat exchanger to be the best solution for that application. And then, with this experience, having experience in several applications, we can tap from this experience and use this experience for new applications, like the one we saw in the previous slides. So using experience from one application and putting it into another application. Another perspective for flexibility is in a market you can have evolution. Data center market is definitely evolving. Every day there are new technologies that are arising, other technologies are changing, are evolving, their legislation is coming, new challenges from the market are arriving. This is not new for us, and it is something that has already happened in other markets. For example, in heat pump market, several times refrigerant has changed, and all these markets had to adapt. So what we can do is to be able to use this capability to adapt to an evolving market also in this application. So just a quick summary of what we saw. We saw a solution for direct-to-chip cooling to maximize efficiency at the rack level. It is compatible with the server and application of different types. It is suitable for existing and also for new infrastructure. On heat exchanger level, we cooperated to optimize the performance by reducing pressure drop and maximizing efficiency. And this was possible because of a partnership between Alfa Laval and Seguente with the aim to produce net zero data centers with the maximum efficiency in terms of cooling and also the possibility to recover the heat with the heater use. Thank you.
Thank you. So I just want to remind the cooling and environments will get together in the afternoon. So in case you have any additional questions, I think we can still take maybe one or two, maybe one, and then if you have additional questions, we can take later in the afternoon. Thank you.